Okay, hello and good morning. Let's get started here. First of all, if you did not take your Chapter 4 test online, make sure you do so tonight or you're going to have to wait until week 9. So let's take a look here. Anyway, you're trying to get t by itself, so you draw a line. And you want to first subtract p from both sides. So you're going to get a minus p equals PRT. Now you want to divide by PR, and you're done. So T is equal to all it is. Okay? Number 2, or 3 rather, this one's a little different. What you want to do is get P by itself. And what you want to do is, since you have 2 of these, you want to factor out a P. So you're going to have P. And when you take the P out of here, you're left with 1. When you take the P out of here, you're left with RT. And so now all you do to get P by itself is divide by 1 plus RT. Now if you don't understand that, that basically brings us to our new section, which is factoring. And we'll talk about that in a minute. This right here, they want you to find the outer portion. It's kind of like a donut. There's the hole. So it's going to be the big circle minus the small circle. That's the plan. So the big circle is pi radius squared minus the little circle, which is also pi radius squared. But the difference here, and I'm going to leave it in terms of pi, the difference here is you use the radius for the big circle, which is 2 plus 3, and that makes 5 squared. And then here, leave pi alone. The radius for the whole is 2, so that's going to be 2 squared. So that's going to be 25 pi minus 4 pi. And so your answer is going to be 21 pi. And if that doesn't make any sense to you, because that's called in terms of pi, and you all had geometry, if that doesn't make any sense to you, then what you're going to do is take 21, clear it out, and then times 3.14. And when you do that, you get 65.94 square inches would be the outer disk or the donut. And that's how you do that. Let's talk about today's work on a new sheet of paper. Copy everything you see here. We're talking about factoring today. So if you've never learned factoring or you only partially learned it, pay attention. Okay? And pay attention from day 1. Let's take a look here. Prime factorization. I want you to factor with 2s, 3s, 5s, 7s, etc. Not 1. Don't use 1. And make sure they're prime numbers. So we're going to go 2. 2 times 30, 2 times 15, and then 3 times 5. So your answer is going to be right here. That's called prime factorization. Okay? Now let's move on. This right here wants the greatest common factor. To do that, you got to factor each one of these. So this is 2 times 3, and then A, because you got 2 A's and a B. Okay. This one is 2 times 2, A, and then B, because you have 2 B's. This one is 2 times 9, but 9 can be 3 times 3, and then A, B. And this is exactly how I want you to do it. All right, so look here. What do they have in common? What's in common? That's what we're doing today. Write that down. That's step number 1 or rule number 1. There'll be about 5 when we're done with the chapter. Okay, so here we go. This one has a 2, this one has a 2, this one has a 2, so take a 2 out. Okay, this one has a 3, this one doesn't have a 3. You can't use 3 unless they all have it. This one's got an A, this one's got an A, this one has an A, so take an A out. This one has an A, this one has an A, this one has an A, take another A out. This one has a B, this one has a B, this one has a B, take a B out. Now, there's nothing else in common, all right? They all have to have it. So your greatest common factor is right here. So it's going to be 2A squared B, and that's called the greatest common factor. Make sure you know that. All right, this one right here says try. So I want you to try this one right now. Break it down. 2 times 10, 2 times 5, A, B, B, B. Okay? 2 times 6, 2 times 3, A, and then 4 B's. Break it down. This one is 2 times 4, 2 times 2, A, B, B. Break it down all the way. All right, now let's look and see what's in common. We have a 2, a 2, and a 2. Take a 2 out. We have another 2, another 2, and another 2. Take another 2 out. This one has a 5, no 5s. This one has an A, this one has an A, this one has an A. Take an A out. This one has an A, this one has no more A's. You can't use A's. This one has 2 B's. This one has 2 B's. This one has 2 B's. Take 2 B's out. Now let me see if there's anything else in common. This one has a B. This one has a B. This one doesn't have any more B's left. This one has a 3. No 3's. No more A's. This one has an A, this one has an A, but this one does not have an A. This is your answer right here. So it's going to be 4AB squared. It's called your greatest common factor. Any questions on what I did? All right, let's go on. Now, if you need more help, you can go online. There'll be other people that can help you. Just type in greatest common factor. Now let's take a look at today's work here. Another one. Copy down number 1. All right, so factor means you take out what's in common. So it's going to be 2 times 6, 2 times 3, y. This one's going to be 2 times 10, 2 times 5, and a y. So circle only the prime numbers. 6 is not a prime number. That's a composite. Anyway, we have a 2, take a 2 out. We have a 2, take another 2 out. We have a y, take a y out. So your greatest common factor is 4y. Now, if you take out the 4 and the y, you're left with 3y. If you take out the 4 and the y, you're left with 5, and that's your answer, and that's how you factor it. How you check it is, you go 4 times 3 is 12, 4 times 5 is 20, y times y is y squared, y times that is y. There it is, and that's how you check it in your head. Okay, try this one. This one is A, B, B, A, B. So they have an A in common, take it out. This one has a B in common, take it out. So you're left with AB on this one, minus, and then here, nothing's left, but you have to put a 1 as a place value. A times A squared, B times B, B squared, and then AB times 1 is AB. So if you take it all out, you have to have a 1. All right, this one right here is basically the same thing. The only difference is you can't have a negative in front, so you must first take out a negative. When you take out a negative, you change all your signs. This actually changes to a minus, and this changes to a plus. Okay, so now what you do is break this down and do it the same way, but that minus is going to be part of your answer. Just remember, if there is a minus, you have to take that out first. Here's your assignment right here. Start working quietly, and I will help you if you get stuck. Pay attention to factoring. All right, let's talk about geometry now. Let's take a look at this here. All right, so for geometry, what we have is OOO, so opposite sides, and this is for a parallelogram, or congruent. Opposite sides are equal. No, opposite sides are parallel, and opposite angles are congruent. Consecutive angles are supplementary, 180, and diagonals bisect each other. These are the 5 properties of a parallelogram. Look here. If this is a parallelogram, we'll assume it is, then this angle plus this angle adds up to 180. So you're going to say 50 plus x plus 60 is equal to 180. Then you get your calculator. You subtract 60, you subtract 50, and whatever you get is your answer. So that's 110. So 180 minus 110, because 60 and 50, 110 equals 70. So this angle has to be 70 degrees. This is 120 plus 60 makes 180. This one, if it's a parallelogram, these are equal. So you put 5x plus 2 is equal to 3x minus 1, and you work it out. 3x is smaller. So what you want to do here is subtract 3x from both sides. When you do, you get 2x plus 2 is equal to a negative 1. You want to subtract 2 from both sides and get 2x equals a negative 3. And then you want to divide by 2, and you got your answer. All right, on a new sheet of paper, copy this one down. This one right here, these have to add up to 180 because they're consecutive. They're in order, this one, this one. So you're going to say 30 plus 3x plus 4 is equal to 180 degrees. You're going to add these up and then subtract and then divide by 3. All right, on a new sheet of paper, copy this down. Proving a quadrilateral is a parallelogram. So the question is this a parallelogram? And the answer is no, because opposite sides are not equal. So no, opposite sides are not congruent. Or not congruent. There it is. It's simple. Let's take a look at another one. Draw this diagram right here. Is this a parallelogram? Well, this angle is equal to this angle. Now the whole thing, it's got 4 sides. Remember 4 minus 2 times 180, that formula? That should come out to 2 times 180, or 2 triangles, and that's going to be 360 degrees. So all of this should add up to 360. So it's going to be x plus 153 plus 27 plus 153 has to equal 360 degrees. Let's see what happens. We want this one to be the same as 27. So we take our calculator and we start working this thing out. So the calculator is right here. We're going to take 360, make sure your calculator's on your desk, minus 153 minus 27 minus 153, and I get 27. So since this opposite angle here is equal to this one, we're going to say yes, parallelogram. Opposite angles are congruent. Okay, I want you to write the reason as well. Draw this diagram. The question is, what must x and y be? Well, they're giving us the numbers here, so we got to plug them in. So you're going to have 25 plus 15. That's going to make this angle 40 degrees when you add that up. So we got 40 degrees. This one is 2 times 25, which is 50, and 50 minus 10 is 40 degrees. So right now, opposite angles are equal, so we're okay. Let's try y. 5 times y, or 5 times 30 rather, is 150. So 150 minus 10 is 140. So this angle is 140. We'll see if this one's 140. 3 times 30 is 90, and 90 plus 50 is 140. So now we have opposite angles are equal. The question is, does all of this add up to 360? So let's see. We're going to take all of these up. So 140 plus 40 plus 140 right here, and then plus 40. Let's see if we get 360. We do. This one is yes. Opposite angles are congruent. Okay, good. Now this one, draw this diagram. It says find P and Q to make this a parallelogram. Well, to make this a parallelogram, we want the diagonals here, these pieces, to be equal. So 7p plus 1 has to equal this one, and then this one has to equal this one. So 2q plus 3 has to equal 3q plus 1. And what you do is you work that out. Excuse me. Now, I'm not going to sit here and work it out because you should be able to. And whatever you get is your answer. Okay? Here's your assignment for today. Parallelograms. We're proving if they are parallelograms. So there it is, and I'll see you in class. Have a good morning.